Hello, welcome to Math Matters. I'm Mrs. Smith. Today you are going to learn how you can use arrays to solve multiplication problems with larger numbers, and how to communicate your thinking using pictures, numbers, and words. Here are some things you will need: some paper and something to write with. I'll give you 30 seconds to go get those. The problem we're going to solve first is 3 times 12, which is also 3 rows of 12. So let's make that array. Here's one row of 12, another row of 12, and a third row of 12. We can also think of this array as an area model, and we need to figure out how many squares there are that cover it. One way to do that is to think about facts you know that could help you. You might not know 3 times 12 off the top of your head. So what is a fact you do know that could help you figure that out? The first facts that come to my mind are 3 times 1, 3 times 2, 3 times 5, and 3 times 10. I think I'm going to use 3 times 10 to help me solve 3 times 12, because 10 is close to 12. Now I'm going to split the array to show the 3 times 10 like this. Now we can see how we split or decomposed our 12 into 10 and 2. We still have 12 in each row. We're just going to think about it differently and in these groups. On the left side of the array, we see 3 rows of 10, which is 3 times 10, and that equals 30. What dimensions or equation can we use to represent the right side of the array? It's 3 times 2, which equals 6, because in this section of the array we have a 3 by 2 rectangle, or 3 rows of 2. Since we know there are 30 squares on the left side of the array and 6 squares on the right side, how many total squares are there? We can also think about this as the area of the rectangle and how many squares can cover it. To figure that out, all we have to do is combine the 30 and the 6 to give us 36. So 3 times 12 equals 36. Let's try another example. This time, work with me on your paper and pencil, and we'll do it together. The one we're going to do next is 4 times 14. Let's have a look. Hi everyone. So here we're looking to solve 4 times 14, and we want to use the area model or an array to do that. So here I built a 4 by 14 array. You can see we have 4 rows, and we have 14 going across in each row. So when I think about how I want to figure out how much 4 times 14 is, 14 is not a very friendly number. So I'm trying to think of how I might split up that 14. And one way I'm thinking about doing that is to think about that 14 as 10 and 4, because 10 is a friendly number. So if I split that a little bit, we can see that now I have 10 going across. Now I have a 4 by 10 rectangle, so 4 rows of 10. And over here, I still have 4 rows, but I have 4 in each row. So you can still see our 14 with the 10 on the top and then 4 more to give us 14 still in each row. Now I can think about 4 times 10. 4 tens is 40. So that's how much is over in this part of the array, 40 squares. And over here, we have a 4 by 4, and 4 times 4 equals 16. Now to find the total, I just need to combine that 40, those 40 squares, with the 16 squares. So 40 plus 16 equals 56. So now I know that 4 times 14 equals 56. So when you use an array model or the area model, you don't have to always represent each square. So you can just draw what's called an open array. So let's look at the open array. Open. So I can just draw a rectangle. So for solving 4 times 14 again, see how I drew the 4 smaller than the 14. So you want to think about drawing it to scale so that it makes sense. And then when I split my array, I can think about, well, the 10, the side with the 10 is bigger than the side with the 4. So there you can see how I split into 10 and 4, and we still have 14 going across the top. So this section we have 4 times 10, which we know is 40, and then over here we have the 4 by 4, which we know equals 16, and then we just combined the 40 plus the 16 to get to 56. So we know 4 times 14 equals 56. So in this one, we happen to split the 14 by its place value. We see 1 10 and 4 ones, and that's how we split this array. But you don't always have to split it that way. You can think about other ways that numbers make sense to you. So let's look at another way we might solve for 4 times 14 using the open array. So we still have our 4, and we have our, I'm going to put my 14 down here for you. 14 going across, and maybe we think another number that's friendly is 5. So maybe we want to split our 14 into 5 and 5. 5 and 5 is 10. And then 4 more makes 14. So then 4 times 5 is pretty friendly. 4 times 5 equals 20. And we have another 4 by 5. So another 20. And then a 4 by 4, which is 16. So now we just combine the 20 plus the 20 to get to 40, plus 6 more is 46. Thanks, Mrs. Sigmund. Let's do one more together. Take a moment to use an array to figure out 3 times 15. Here's how you might have thought about it. Here, I decomposed or split the 15 into 3 groups of 5 so that I could use the fact 3 times 5 equals 15 to help me. You can see those 3 5s at the top of the rectangle. There are 3 sections of 3 by 5 rectangles. So I added those 3 15s together to get 45. So I know 3 times 15 equals 45. Here is one way you may have figured out 3 times 15. Here, I decomposed the 15 into 10 and 5 so that I could solve for 3 times 10, which is 30, and 3 times 5, which is 15. Then I combined the 30 and the 15 to get 45. Now let's look at these two strategies side by side. Take a moment to talk or think about these questions. How are they similar? How are they different? How do these compare to what you did? Today we explored how we can use arrays to solve multiplication problems with larger numbers. Let's take a moment to reflect on what we learned. Share your ideas with someone or write down your answer to this question. How can arrays help you with multiplication of larger numbers? Thanks for watching today. I'm Mrs. Smith. I hope you have a mathematical day and keep on counting.